In the previous videos, we learned about high-pass filters and low-pass filters. Such filters are used for filtering out low frequencies and high frequencies from the circuit. When we cascade these two filters, we get another special filter known as bandpass filter. This is Abhinav from learnelectronicsindia.com, and let's learn how to make a bandpass filter using OpAmps. We'll first make a high-pass filter with gain of 2. So let's have a LM741 IC with plus 12 and minus 12 as supply voltages, and connect a negative feedback resistor and a resistor between the inverting input and ground. To make the RC circuit, we will connect a capacitor to the non-inverting input and connect a resistor between the non-inverting input and ground. So now the high pass filter is done. Now let's make the low pass filter. So to make a low pass filter of gain 2, first we will copy paste the non-inverting amplifier circuit of the high pass filter. To make the RC circuit of the low pass filter, we will connect a resistor between the output of the first op-amp and the non-inverting input of the second. Then we will connect a capacitor between the non-inverting input and ground. The formula for cutoff frequency for low pass filter and high pass filter is same and is given by this formula. So let's have the lower cutoff frequency as 1 kHz and fix CL as 0.01 microfarad. Hence by the formula, RL should be 15.915 kilo ohms. Let's have the upper cutoff frequency as 100 kHz and set CU as 0.01 microfarads. Hence by the formula, RU is equal to 159 ohms. After setting these values, let's run the simulation. To see the frequency versus amplitude graph, let's click on Simulation, Analysis and Simulation. Then select the AC sweep. Let's have start frequency as 1 Hz, stop frequency as 10 MHz, sweep type as decade, number of points per decade as 100, and vertical scale as logarithmic. In the output section, we'll select the output of the second op-amp. In this case, it's V7. And press run to see the graph. As we can observe from the graph, all the frequencies below 1 kHz and above 100 kHz are getting blocked, and only the frequencies between the range of 1 kHz and 100 kHz are allowed to pass through the circuit. Hence the bandwidth of this circuit is given by this formula. After substituting the higher cutoff frequency and lower cutoff frequency, we get the bandwidth as 99 kHz. The resonant frequency of this circuit is given by this formula. After substituting the values, we get the resonant frequency as 10 kHz. Such bandpass filters are used in wireless transmitters and receivers to select specific range of frequencies. You can find detailed explanation along with the multisim file at our website link in the description. This is Abhinav from learnelectronicsindia.com, and thanks for watching.